Welcome to screencast number 2 for Unit 6, Lesson 2, and I'm on page 286. How is star brightness measured? When you look at a star in the night sky, you see that stars vary in brightness. Some stars are bright and other stars are dim. In reality, one star can appear brighter than another star simply because it's located closer to Earth. Okay. So blue heading says, how is star brightness measured? And there's two ways. Here, by apparent magnitude, and here, by absolute magnitude. So we're going to talk about apparent magnitude first. Apparent magnitude is the measure of a star's brightness as seen from Earth. Some stars are actually more luminous or brighter than the sun is. Actually, lots of stars are. If these stars are located far from Earth, they may not appear bright to us. Using only their eyes, ancient astronomers described star brightness by magnitude. They called the brightest stars they could see first magnitude, and the faintest stars that they could see they called sixth magnitude stars. Astronomers using telescopes see many stars that are too dim to see with the naked eye. So before the invention of telescopes, you wouldn't have been able to see them at all. Rather than replacing the magnitude system that was developed by the ancient astronomers, astronomers today, they added to the system. So today, the brightest stars have a magnitude of about a -2, and the faintest stars that we can see with a telescope have a magnitude of +30. And the magnitude scale may seem backwards because faint stars have a positive or a larger number and bright stars have a negative or a smaller number, but that's the way it is. So the smaller the number, the brighter the star. The bigger the number, the dimmer the star. Sirius, the brightest star in the night sky, has an apparent magnitude of -1.46. To the naked eye, the sun has an apparent magnitude of -26.8. Okay, so that's an even smaller number by a whole lot. Okay, so even though the sun is not as luminous a star as Sirius is, we see it as a whole lot brighter because the sun is a whole lot closer to Earth than Sirius is. Okay, so apparent magnitude tells us how bright a star seems to be, and that has to do with, yes, it has to do with how much light they're actually giving off, but it also has a lot to do with how far that star is away from us. Okay, there's a great example at the bottom of page 286, and you notice that there's an instance where the girl is standing with a flashlight 20 meters from her tent, and the tent is not very lit up because the light from the flashlight is so far away. And then she gets closer. Of course, the tent is lit up better because she's closer. And I think an even better example is if you would think about two people at night in a field with they have identical flashlights, but one of them is shining their flashlight toward you and they're standing 400 yards away, and you have another friend standing only maybe 25 yards away. They're holding the same flashlight. Their flashlights are giving off the same amount of light, but that flashlight that's closer to you is going to appear a whole lot brighter, and it's just simply because it's closer. Okay, so that's kind of the way apparent magnitude works with stars. Okay, their apparent magnitude is how bright a star seems to us, and it has to do with their distance from Earth, as well as their brightness. Okay, so let's go to page 287. How is star luminosity measured? When astronomers use the word luminosity, they mean the actual brightness of a star. To measure a star's luminosity, astronomers use an absolute brightness scale called absolute magnitude. Okay, and you will probably hear me use the words luminosity, absolute brightness, and absolute magnitude. And you'll probably hear them all used interchangeably. They're all basically the same thing, okay? At least for our purposes. Okay, so star luminosity is measured with absolute magnitude, okay? The one that we talked about on page 286 was apparent magnitude. Okay. All right, so back to page 287, absolute magnitude. Absolute magnitude is a measure of how bright a star would be if the star was located at a standard distance. Okay, to me that definition is not super helpful. Just think of it as absolute magnitude is how much light is that star actually giving off. How bright is that star actually, okay? Just like apparent magnitude, absolute magnitude uses the magnitude scale. So you have the same set of numbers that you're using for absolute magnitude that you were using for apparent magnitude, okay? And if you look up a star's magnitude, you need to make sure that that you know whether you're looking at absolute magnitude or apparent magnitude, okay? To understand the difference between apparent magnitude and absolute magnitude, let's use the sun as an example. The apparent magnitude of the sun is negative 26.8, meaning for us it's really bright, okay? However, the absolute magnitude of the sun is a positive 4.8, which is typical of many stars. Remember, the sun is sort of a average-sized, average temperature star. It's, you know, not big, big, big and bright, bright, bright. It's sort of average. Now compare the sun, which is located 8.3 light minutes from Earth, to Sirius, which is located 8.6 light years from Earth. Sirius has an apparent magnitude of negative 1.46 and an absolute magnitude of positive 1.4. Okay, so if we look at the absolute magnitude of Sirius, positive 1.4, and the absolute magnitude of the sun, which is positive 4.8, remember that the smaller number means brighter star. So Sirius is much more luminous than the sun is, meaning Sirius gives off more light than the sun does. Okay? All right, look at the table down at the bottom of page 287. And they give you 3 stars, the sun, Sirius, and Betelgeuse. They give you the distance from the Earth, apparent magnitude, and absolute magnitude. Okay, so obviously from the table, which star is closest to us? The sun, because it only takes light 8.3 minutes to get from the sun to us. It takes 8.6 years for light to get from Sirius to us, and it takes a whopping 640 years for light from Betelgeuse to get to us. Okay? Now look at the apparent magnitude, meaning how bright does a star seem to be? Well, the smallest or the most negative number wins. So obviously the sun is the brightest to us. Okay, it seems the brightest. But if you look at absolute magnitude, Betelgeuse wins out big time. Okay? Because remember, smallest numbers mean brightest stars, okay? So for absolute magnitude, the sun comes in dead last out of these 3, okay? Betelgeuse is the brightest, Sirius is next, and the sun is the dimmest. Okay. I'm going to pause and I'm going to show you guys what I wrote for these 2 pages. Okay, going back to page 286, you'll notice that I underlined several things, and you need to go back and do that as well. Also, to the left, I reminded you that apparent magnitude is how bright a star seems to be from Earth. Okay? On page 287, there are several things that I highlighted, but I also pulled out a couple of those terms. Remember that a synonym, synonyms are words that mean similar things, okay? They're different words for the same thing. So absolute brightness, luminosity, and absolute magnitude all mean basically the same thing for us, okay? Absolute magnitude, remember, is how bright a star actually is. How much light is that star actually giving off? Okay, so there is a difference between how bright a star seems to be and how bright a star actually is. Okay, and a lot of that has to do with how far is that star from Earth.